Alrighty, so we're continuing on. Really, this is the last topic of this unit. It involves knowing how to factor algebraically a polynomial, how to solve a polynomial equation, and then extending into today is solving a polynomial inequality. We've already done graphically how to do that. We went through solving algebraically quadratic inequalities and looked at different methods. We're really going to do kind of a basic method of those ones that we learned in the for the quadratics. Do a number line, test some values, use the factors, to kind of use our head rather than showing the value of each factor in a chart. Okay. Based on the fact that for your exams, your tests and your exams, you're allowed to graph the calculator anyway in this course. When you get to calculus, then you do need to show some work, whether it depends on your teacher if you have to do that chart, or again, if they're okay with just a number line with test values, like we're going to do today. Okay? So, basic steps. In all of these, if we're solving a polynomial equation, move all the terms so you get one side equal to 0. Okay, then factor as much as possible using the factor theorem. So find your potential zeros. You can graph it on your calculator because you have one to see any of what one might work. Show your division, synthetic or long division. So show your algebraic work. Then solve each factor to 0. Okay, because these have the 0 in them. One side has to be 0. Then test the values between those roots to see if they satisfy the inequality. So first one, here I would look at, okay, one side's already 0. So the potential roots of corresponding equation is equal to 0. Notice how there's coefficient of 1, nothing shown out front. So we really only care about that constant term. So factors of 6, 1 and 6, 2 and 3. Okay. Positive or negative. One has to be positive, one has to be negative for each factor of 6, negative 6. Okay, so you can graph this, x equals 3 plus 2x squared minus 5x minus 6. Oh no, that's not good. 2x cubed out of the exponent plus 2x squared minus 5x minus 6. I'm going to do a standard. I think I've changed this recently. Multiply. So you can look at that and know what the factored form is right away. Okay? Looks like there's an x-intercept of 2. There's x-intercept of negative 1. X-intercept of negative 3. Okay, so you could come up with the factored form of that inequality and solve it, but it says solve algebraically. That's not algebraically on your calculator. You're using it as a tool to help you. So from this, I'm going to choose the first positive one. So x equals 2. So x equals 2 is a root of the corresponding equation. So now I'm going to factor then by x minus 2. You've chosen the correct root. You should get 0 as your remainder. Notice how degree 3, and there is a term for every descending degree. Always take a look. Maybe there's something missing, right? Maybe it doesn't have an x squared, so then you would put a 0 in it. Okay, so that's good. You got 0, so we know, pretty sure anyway, that we did it correctly. All right, so now I'm going to show that, in fact, the factors that I have. And include the inequality now. And then you can factor that again. You kind of know that already, because we did graph it and saw integer roots. Okay, so this is where I'm going to draw a number line. So it's representing x. And so here, my solution, so 2, -1, and -3. Okay, so just plot those on there. Then choose some test values. So a value for x that's bigger than 2, let's say 3. Okay, so I don't go back into the beginning. That's a lot of mathematical work. Really easy if you put it back into the factors. But take a look at your quadratic notes for quadratic inequalities. We put it back in the factors, but there's a whole chart. I'm not doing a chart. I'm just showing it here, putting it in to each factor in my head. So 3 minus 2 is a positive. 3 plus 3 is a positive. 3 plus 1 is a positive. Positive times positive times positive is positive. Okay? Then here, x equals 0. 0 minus 2, negative, positive, positive. So overall, that's a negative. X equals -2. It's going to be negative, positive, negative. So overall positive. X equals -4. Negative, negative, negative. If they pass through, if they have multiplicities of 1, then the signs are going to alternate there. If you don't show your test values like that, then you need to show basically a graph. Okay, so if you didn't do that, then you would do this. Okay, and then circle the parts that are above. All right. And then remember that this does not include the values where the polynomial is equal to 0. So it's going to not have equal signs in them. So we're looking for this interval here and this interval here for these parts. So one or the other in terms of showing your work. And so your solutions then are between -3 and -1. And then greater than 3. I'm just going to fix this kind of squishy here. Yep. Oh, sorry, 2. Yeah, 2. So I was looking at the red value had that 2, greater than 2. So, thank you, sir. Okay, so really just one step more from yesterday. Yesterday we were solving equations. Really we have to do that to find these values. And then now we do a number line. If you want to do a whole chart, you can, but I wouldn't. Number line test values or number line with graph. Just be aware that when you get to Math 31, you won't have a graphing calculator to graph it. So getting used to testing some values might be helpful for you in the long run. Okay. So let's do another one. Okay, so then we can graph this. And again, you could figure this out graphically, but you might be asked to do it algebraically. So this one looks like 2, -2, -4. I always like to choose the positive ones, although really that ends up being negative in your binomial. So really totally up to you. But just always check to make sure it's 0. Because it could be very close to that, and with the pixel sizes of your calculator, you can't tell. So it looks like 2 works. So x equals 2 is a root of the corresponding equation. So then we're going to divide, so x minus 2 into 1, 4, -3, -14, -8. Okay, so we got 0, so that's good. So now we've got it down to a cubic. So we still need to factor again. You want to go right from here, you can. Again, looking at your polynomial function there. Maybe another one at -1. So trace -1. Okay, or you could do the -4, it doesn't matter. So x equals -1 is a root. Then we'll divide by x plus 1. And you can use this as you can just extend your synthetic division chart if you like, or you can draw a new one. Each time you do it, it's going to move, that remainder column is moving to the left. Remember yesterday I didn't move mine, and so then it was kind of weird. I realized that I had to do that. So here, 1, 1, 5, 4, 4, and 0. Okay. So then, so far, we have x minus 2 times x plus 1 times x squared plus 5x plus 4. Then what was it? Less than 0, I think? Yeah. Okay? Whatever, if it's an equation, you need equal 0. If it's an equality, you need less than or greater than, whatever it is, 0. If it's a function called, say, p of x, that you're just asked to factor, then it's p of x equals. So don't drop the 0 or drop the p of x. Okay, if there's no name to it and it's not an equation, then don't add in y equals. Okay, so keep it whatever type of function or expression it is. So then factor this trinomial. Okay, so that factors to x plus 4 times x plus 1. Notice how there's a repeated factor there of x plus 1. So you could show that as x plus 1 squared times x minus 2 times x plus 4 less than 0. Oops. Sorry. Less than 0. Okay. So your zeros here are -4, -1, and +2. So testing x equals 3. So if you want to put it back into the square, it might be a little bit faster, right? In here, this is always going to be positive because you're squaring. Even this, if the bracket was a negative, it's going to be positive. So really, we only care about these two. So 3 minus 2 is a positive, 3 plus 4 is a positive. That would be -2 times +4, that's a negative. Another negative, so that would be -4 times the positive is a negative. And then let's say -5. So that's going to be negative times a negative is a positive. So in this case, it doesn't alternate, and that's because it has a multiplicity of 2. So if we're looking for where this is less than 0, we're looking for this interval here and this one here. Can I do a whole circle around that? No, why not? Right. Because no equal sign there, right? At this point, it's equal. So that's why I did 2 circles, basically. So my solution here is, now there's a couple ways of showing it, but this would be probably the most common way. Okay. Or, I guess you could say, do the whole interval, -4 to 2, where x is not equal to -1. Okay, so you can do it that way as well. Now, if you had done it by graphing, then what would you have here? You have and then you have to realize, okay, so positive leading coefficient, so it's going up, and then you do have your graphing calculator. And so it's multiplicity of 2 at -1. So it's going to, let me just extend this a little bit. So if I were to sketch this, it would go down like this. Okay. Move that over a little bit. So there, everything that's below the x-axis is this part except for that point there. So this here and this here. Okay, okay, so very similar. I just wanted to do one more. Where is it? Yeah, we'll do this one. So, third one here. Okay, so testing x equals 1 works. X minus 1 is a factor. Synthetic division could get a remainder of 0. Show it in factored form, but then what do? Can't factor x squared plus 5x plus 1. Quadratic formula, exactly. I want y to be greater than or equal to. Okay, so x equals 1 for that factor. Okay, and then this one, can't factor it, so we're going to use the quadratic formula. Again, show the variable. Maybe it's not an x, maybe the equations are all in m's. So m equal whatever the variable is. Right? So here, -5 plus or minus, I think I still have it up on the board here. You forget. What is it? And so we're going to want exact values. So 25 minus 4 is 21. Okay, so your solutions, if this was just an equation, I'd write that out and set brackets together. 1 comma -5 plus or minus root 21 over 2. But we're not done yet. We're solving the inequality. So now you want to think about where these numbers lie. Like, you do have a graphing calculator, but estimating your head. So root of 21, so that's a little, 21's a little less than 25, right? So this is going to be a little less than 5. If we're adding that, that's still going to be negative, right? If it's a little less than 5 over 2. So that's going to be around -1/2, okay? So it's going to be the smallest value. So this would be -5 minus root 21 all over 2. Oh, sorry, that's not going to be the most negative. I'm just going to move that. Oh, sorry. That's going to be the most negative. Let me do this again. So This is going to be about 5, a little less. So if I subtract, that's going to be a little less than, close to negative 10, but not quite, divided by 2, so close to negative 5. So that is on the left. Then if I add something that's close to a little less than 5, it's still going to be negative, but closer to negative a half. So that's going to be my next one. And then 1. Now you do have your graphing calculator, but I'm just trying to do something about it. Okay, so let's say x equals 2. Now that's where it gets a little bit, you wouldn't want to go back in here. You want to go look at your factored form. So this can't be factored, right? So I'm going to put it back in there, though. It is a factor. So 2 minus 1 is 1, so that's positive. 4 plus 10, that's going to be positive. So positive times a positive is a positive. Remember how we said this is still going to be less than 0, it's going to be a negative. So I'm going to put 0 in, because that's an easy thing to check. So that's going to be a negative times a positive, which is negative. And if this is degree 3, and we have 3 different roots, then it's going to alternate. So next one should be positive. We think about this, what did I say, negative, around a negative half, around negative 5. So let's do x equals negative 2. So what's that going to be? Negative. And that's going to be 4 minus 10 plus 1. That's going to be a negative. So a negative times a negative is a positive. And then this one, let's do, say, negative 10. This is not quite negative 10. So that's going to be negative 11 times 100 minus 50 times a positive, basically. Negative times a positive is a negative. So we want where it's greater than or equal to 0. So this, and including those endpoints. So we want equal signs. That. Okay, so okay, so trace 1, enter. Okay, do that again. Okay, so there you can see equals 0. You want to put this value in, so in trace, I would go, okay, bracket, negative 5 minus root 21, close the bracket again, divide by 2, and you can see it's negative 2 e to the negative 12. That times 10 to the negative 12, scientific notation. So that is essentially 0. It's not 0 because of the pixel sizes. Another way to check this would be, okay, in my graph, if I want to find that 0, so second trace 0, I'm at the left boundary, cursor to the right boundary, enter. Then I'm going to copy out that x value into my calculate screen, and then I'm going to put in bracket -5 minus root 21, close bracket, divide by 2, and then I get the same thing. So you can test that way. Okay. So really, the only thing to ever worry about, more so than all the other types of factoring and solving that we've done, is just what's the sign of the inequality? Does it have an equal sign? If it doesn't, then maybe it splits it up, or if it does. So, for example, this is all one. So, for example, here, if I said, let's do greater than or equal to 0, then what would that be? That would be x less than or equal to -4, x equals -1, and x greater than or equal to 2. And we've already done that graphically, but just remember algebraically. Still have to think about the same things. Okay, so that's it for today.